So we want to take a look at naming triangles with regards to their sides as well as their angle. So we're going to have three different names for these triangles, depending on whether we're talking about the sides or their angles. Um, and every triangle can actually get a name to describe both of those things. So an acute triangle is a triangle where all three angles are acute, right? And by that we mean less than 90 degrees. Okay, all three angles are acute, less than 90 degrees. So if we were to draw one of these triangles, we might sketch it like this right here, and maybe we would have some degree measurements in there, but in general, just make sure that none of them are right angles and none of them are obtuse. So an obtuse triangle is defined when, or we have an obtuse triangle when we have one angle that is obtuse, right? And obtuse is greater than 90 degrees, but also less than 180 degrees, right? In between those two measurements. So if we were to sketch an obtuse triangle, it might look something like this, with this guy at the bottom being our obtuse angle, okay? A right triangle is where one angle is right or equal to 90 degrees. So if we were to draw this triangle, we would want to make sure to have a marker in there for that 90-degree angle. So those are our names based on the angles. We're going to add one in here though that we did not talk about, or we don't normally talk about, but it is pretty important. We're just going to add this at the bottom. This is an equiangular. Equiangular triangle. All right, so this triangle most notably has all three angles are congruent, right? Their measurements are equal. So if we were to draw this triangle, we'd have all three angles and we'd have congruency marks on them there. Okay, so those are our names based on angle measurements. So let's take a look at how we can name triangles based on sides. So the first thing we have is called a scalene. This is where no sides are congruent. So if you want to think about drawing this triangle, we might have a triangle that looks a little bit like this, and if we were to place congruency markers on them, every single side would have a different number of tick marks because none of them are the same. An isosceles triangle is where two sides are congruent. So when we draw an isosceles triangle, two of the sides are congruent. Now, a side note about isosceles triangle, which we'll take a look at later, is if two sides are congruent, their opposite angles are also congruent. We'll use that information a little bit later. That's just bonus for now. Okay. And then last, just like we have the equiangular triangle, we have an equilateral triangle. So equilateral sides, that's where all three sides are congruent. So if I drew a triangle like this, all three sides would be congruent. And kind of similar with the isosceles, where the angles opposite the congruent sides are congruent, the same thing happens in an equilateral, which means if we have an equilateral, we also have an equiangular triangle. Okay, so we don't need to know that quite yet, but it's good to keep that knowledge in the back of your mind because we might use that a little bit later. Okay, so we're going to be drawing some triangles here. So if I want to draw an acute isosceles triangle, if you want to add degree measurements in here, you can, but I'm just going to draw this so that none of my angles look obtuse, and I'm not going to put any 90-degree markers on here for a right angle. And then I just need to make sure that I mark two of my sides as congruent. That's for that isosceles part. So again, an acute equilateral. I can draw this very similar. Equilateral just means all three sides are congruent. So when I add my congruency markers, I need to indicate that all three sides are congruent. Acute scalene. I can draw this guy and add my congruency markers so that all three sides are different. And finally, a right scalene, I can do the same thing. This time I do have to indicate an angle because we do need to indicate that right angle. And then the scalene where all three sides are different.